All right, this is our second equations lesson on solving subtraction equations. So first one was on all the problems were addition equations. This time we're going to involve subtracting equations. So go ahead and get your notes set up. Get your title, your learning target, and your I can statement here, and then we'll go ahead and get started. All right, for this lesson we're going to do things just a little bit different. First we're going to start with some word problems. We're going to practice drawing our bar diagrams, kind of model what's going on in the problem, and it'll hopefully help you start to see what you need to do to solve an equation like this by kind of seeing it going backwards. So if you remember from our expressions unit for a subtraction problem, it's going to be some amount, and then you're going to come back underneath by some other little amount. So you had something, you subtracted away some of it, so now there's only a smaller portion of it left here. We're going to do that for our bar diagrams, but we're going to use it to actually model what's going on in these problems. So this first one says Megan's bowling score was 39 points less than Char's. Megan's score was 109. What was Char's score? Well, we don't know Char's score. That's our x. So when we draw our bar diagram, we start with our variable, in this case, x. Now, in the problem, they tell me that Megan's score was 39 points less than Char's. So that means you take Char's whole score, and then we're going to subtract away 39 points. Remember, for subtraction, it kind of comes back underneath of it because you're kind of going back down into a smaller number because you subtracted some of it away. Now, you'll notice this gap here, what's kind of left over after we subtracted away 39. Well, they tell me that. They tell me Megan's actual score was 109. So we had the equation x minus 39. So Char's score minus 39 to get to Megan's, and we know it's going to be equal to 109. That's what the problem gave us. Well, look at our bar diagram. What do you think you'd do to try and figure out what this total amount x is? Well, that big piece is the same as this smaller 109 plus the 39. So think of how we solved our equations before. Before, when we added something to solve it, we did the opposite. We subtracted. Here, if you notice, we need to add these two pieces together. So, pardon my little scribble there. Let's get rid of that. What we need to do is they subtracted 39 points from Char's score, so we need to put it back. We need to add 39. But like we talked about before, you have to treat both sides of the problem equally. So they took away 39, we put it back. So it's kind of like we're back to the starting point, which is x. Over here, 109 plus 39. Do a little addition, and we get a total of 148 points. So Char's total here should be 148, which is 109 plus 39. And again, we can always do our check, or we should always do our check. Plug in 148 for x. Minus 39. Is 148 minus 39 really 109? Well, you can do a quick subtraction problem off to the side, and we'll find that, yes, that is the correct answer. So we've checked our work. So let's try another one. It says Zach gave 5 trading cards to his sister. Now he has 41 trading cards. How many did he have originally? That's the part we're missing. We don't know. So let's call it W. So Zach started with some amount, W. We don't know what it is yet, and that's okay. We're going to find that out. But he gave 5 cards to his sister. So that means however many he had, he gave away 5 of them to his sister. So we need to subtract away 5. And we show that we came back by 5 from our original total. Now it says, after doing that, he has 41 cards left over. So this leftover piece, after we got rid of those 5, is 41 cards. So if we write it as an equation, we would see W minus 5. His total originally, minus the 5 he gave to his sister, is equal to 41 cards. Well, let's find out what our answer is. If we want to know this big piece here, W, pardon my bad outlining, this whole piece is the same as this piece here plus this piece here, 41 plus 40 plus 5. So if you look at our equation, what do we have to do to be able to do that same thing? Well, they subtracted 5, so we want to put it back. We want to add 5. So we do the same thing over here. So that bar diagram, kind of looking at it and going, oh, I really want to add those two numbers together, helps remind yourself, what do I need to do in order to solve this equation? What I really want to do is, they had subtracted 5 away. I want to add it back. I want to kind of put us back to the starting point, whatever Zach started with to begin the problem. Well, 41 plus 5 is 46. So remember, always draw that line down through the middle of the problem. Whatever they did to your variable, we want to do the opposite. They subtracted 5, so we added 5. We want to kind of cancel that part out, so we're just left with our starting point. But remember, you got to treat your equation equally. You got to do the same thing on the right-hand side that you did on the left-hand side. So let's do a quick little check. Put in 46 for W minus 5. Is that really 41? It is, so we're good to go. So let's go ahead and try it with just some regular problems. This time we're not going to draw out our bar diagrams. We're just going to go ahead and solve it. So first thing we always do before we get started, draw a line down through the middle. And then we look at the side with the variable. So we start with some amount f and they subtracted away 1. Well, I need to put that 1 that they took back. So the opposite of subtracting is to add back that 1. But you always have to keep both sides of the equation equal. So you got to treat them equally. So if I added 1 on one side, I have to do the same thing to the other. Subtracting 1 and adding 1 kind of cancel each other out. They're kind of opposites. And they just leave us with our f. 6 plus 1, or 5 plus 1 is 6. You have to show that work every time you do one of these problems. It's not optional. You can't skip over it. You have to prove to somebody, how did you solve that equation? We don't want to just take your word that you say that 6 is the answer. Then you also need to do your check. Put in 6 in place of f. Minus 1. Is that really 5? Well, yeah, 6 minus 1 is 5. So we're good. 2 is equal to e minus 5. So again, we draw our line down through the equal sign. This one's a little different, that e is on the right-hand side, but it doesn't matter. Start on the side with the variable and ask yourself, what did they do to e? Well, they subtracted away 5. They took 5 away from it. So I want to do the opposite. I want to put that 5 back. But I have to do the same thing to both sides. I have to treat both sides of the equation equally. So I'm going to add 5 on the other side. 2 plus 5 is 7. Over here, they had subtracted away 5. I put the 5 back. So I kind of undid that work, just leaving me with e. So my solution is 7 is equal to 8. Again, always double check your answer when you're done. 2 is equal to 7 minus 5. Put in a 7 in place of our e. Is it true that 7 minus 5 is equal to 2? Yep, so we're good to go. Last two. 2.1 is equal to z minus 6.3. Doesn't matter that it's a decimal. We treat it just the same way we did before. Split the problem down the middle. Z minus 6.3. We want to know just what z is. So they took away 6.3. So we need to add it back to get us to where we started. But treat both sides of your equal sign the same. I'm going to add 6.3 on both sides. They took it away. I put it back. So I kind of return it back to its original point of z. 2.1 plus 6.3 is 8.4. Last step, check your answer. 8.4 minus 6.3, is that really equal to 2.1? Well, 4 minus 3 is 1. 8 minus 6 is 2. So we're good. You always need to double check your solution. Last one, h minus 1/4 is equal to 1/4. So we start with something, They subtracted away 1/4, and I'm still left with 1/4. But I want to know, what did I start with? Well, I draw my line down through the middle. They subtracted 1/4, so I'm going to add 1/4. But I have to do the same thing to both sides. Those two cancel each other out, and I'm just left with my original amount h. 1/4 plus 1/4 is 2/4, which of course we always simplify to be 1/2. Okay, we can double check. 2/4 minus 1/4. Is that really equal to 1/4? Well, it is, so we're good. So to finish this one, I want you to read through this problem. I want you to draw a bar diagram, write and solve your equation, and then we're going to go over it together tomorrow and see how we did when we start class. Okay, so this time it's all on you. You try it, look back at the examples we did, see how you can do on your own.